Today, let's talk about arrays. We'll discuss what they are, how do they work, why are they needed, and what are some of their limitations. I am Imtiaz Sayed, and let's get started. Let's take a look at the definition of arrays with an example. It is a fixed-sized collection of elements, each having the same type and size. Let's break this concept down and understand it with a simple example. Let's say we have an egg tray which has a capacity of 3 eggs. But how does this egg tray relate to an array, right? This egg tray, like an array, also has a fixed size. It is a collection of elements, and all of these elements are of the same type and size. So, this egg tray has a fixed size as it can contain only 3 eggs at a time. It is a collection of elements, which in our case is eggs. They are all chicken eggs. You cannot fit an ostrich egg in here, right? So, we can conclude that all the eggs need to be of the same type and size. Now that we have understood with an example what an array is, let us now see how to implement them. These examples are based on C, the language. The syntax may differ with different languages. Let me jog your memory on how to create variables in C before we move forward to arrays. Here we have declared three integer variables. We have assigned the variable a value of 10, b, a value of 20, and c, a value of 30. Now we can print any of these values as shown here. In C, we use the printf function to display the output. We have given it two arguments. The first is %i, which acts as a placeholder for an integer value that we want to print. The \n within the same argument is an escape sequence that represents a new line to be printed at the end for beautification of the output. The second argument is the variable whose value we want to display in place of %i, the placeholder. This will give us the value 10 when executed. Now that we understand this, let's move on to the array implementation. Like we said earlier, arrays have a fixed size. Therefore, we need to mention how many elements will this array comprise of explicitly. We do so by specifying the type, the variable name for the array, the box brackets like shown, and within that we enter the number of elements we want in this array. Now, we have acquired three spaces where we can store integer values. We can do so by using something called indexes. Indexes simply indicate the position of an element in the collection. The indexing here starts from 0. We are using these indexes to store integer values into a particular position in the array. So we basically specify the variable name followed by the box brackets within which we specify our index. Now we can use the equal to operator to assign this position an integer value. In such a way, we assign the first position the value of 10, the second position the value of 20, and third position the value of 30. In the first line, we wrote 3 within the box brackets. We meant give a space for 3 elements. Therefore, because our indexes start from 0, we can only store values up to the index of 2. If we try to store a value at index 3, we will receive an error message. Now, as the final step, we are picking up the previously stored values from each index within the array. Previously, we used the same printf function. Everything stays the same, except now to access the value, we want to use the name of the variable followed by the box brackets containing the index of the required value. This will also give us 10 when executed. Hopefully, the difference between storing and using variables and arrays is clear. Let's quickly summarize the steps we took to implement arrays. The steps can broadly be divided into three parts: creation of the array, giving it values, and accessing those values. These are technically called initialization, assignment, and retrieval. C also provides an alternate syntax that can be used to implement arrays. Using this syntax, you can initialize as well as assign values to your array in a single line. In this syntax, you don't need to specify the number of elements you require, as this will be inferred from the number of elements you have provided. Now let's move on to the most common question. Why even use arrays when variables get the job done in a much less confusing way and can avoid all this confusing syntax? To convince you that arrays are incredibly useful, let me propose the following scenario. Your school just conducted a test. For the sake of this example, let's assume that you have three students: John, Olivia, and Jake. You want to store all their scores. Let's assume John scored a 93, Olivia scored an 87, and Jake scored a 73. First, let's look at the variable approach to storing these. Here, we can create a new variable for all their scores and print them as shown above. This seems simple enough, right? Then why even need arrays? Let me ask you the following question. What happens when there are more than 3 students who want to take the test? It is possible that there may be even more than 50 students or even more than 100. In such a scenario, do you think the variable approach would work? To store so many students with the variable approach, we would encounter so many problems. One is where we would have too many variable names to remember, and possibly two students could even have the same name, right? So, this is basically just bad design. Now, let's look at the array approach. Here, we have just one variable name called scores. 100 here represents the number of students who took that test. Now, we can store up to 100 values in a systematic way without worrying about repetitive variable names and even remembering 100 variable names. This is a much more elegant solution. I hope this scenario could convince you of the importance of arrays. Now that we know why arrays are useful, let us dive into how they are actually stored in memory as opposed to variables. The grid view on the right represents the computer's memory. The number at the bottom of each box represents the location of that particular block of memory. These numbers are hexadecimal values. This block is simply a container with an address. These containers are where the values of the variables we create are stored. Let us see how this works. When I create a variable a, the value of variable a is stored in block 0x101. Similarly, the value of variable b is stored in block 0x106, and the value of variable c is stored in 0x108. These spaces are chosen based on numerous factors. There is no guarantee that if variables are created one after the other, that they will be placed next to each other in memory as well. Also, on the side note, this is a very oversimplified memory representation. The speciality about arrays is that it stores our data in contiguous memory locations. Contiguous means that all the values in the array are stored in consecutive memory locations. Here, space is reserved from the start when we specify the number of elements we require as shown here by the red box. Now all values we store will be stored in those memory locations only. The consecutive nature of arrays is what allows us to use indexes for assignment and retrieval, as these indexes of the array are in simple terms mapped to the memory addresses. Hopefully this gave you a clear understanding of how variables and arrays are stored in memory. Now that we have discussed arrays thoroughly, it is time to discuss its limitations. For starters, we can only store homogeneous elements, which means elements of the same type and size. If we try to store a float value, which is a value with a decimal point, it will result in an error. Once we set the length of an array, we cannot change its size later on, in the code or at runtime. This is one of the biggest limitations of an array. A solution of this would be to create a new array of a bigger size and copy the old array into the new larger array. But this is extremely costly, as if we have an extremely large array, we would have to copy too many elements and too many values each time an additional element was needed, right? So every time you'll have to create a new array and then add all the previous things into it. It's just a whole mess, right? So this is a bad design. To combat the problem of fixed size, we have another data structure called linked lists, which we will cover next time. Thank you for watching this video. If it cleared up the concepts of arrays for you, do leave a like so I can know this video helped you. Do leave any feedback or questions you have in the comments below. Thanks again.